Hi guys, I hope you guys doing good. Today we're going to learn the next lesson, section 2.6, which is chain rule. This section is not long. It's a short lesson, but this to learn this we need the composite functions, right? Don't worry, I'm gonna remind you guys what composite functions with an example. Alright, so let's go to today's lesson. Alright, now we want to learn chain rule. I said we need to know composite functions. We did composite functions in class, but I'm gonna remind you with this example. Find f composite g. This is not dot, f composite little circle, if fx equal to x to the power 23 and gx equal to x to the power 3 plus 11. Right? When finding composite function, what we do is we want to find f composite g, which means f composite g in simple means f of g of x. Right? Clearly we see f and g, they both functions of x, so f composite g means f of g of x. Now fx is x to the power 23. Right, let's see. Now if this part is x, fx is x to the power 23. Let me use a different color. Now I know when we use red, it's hard to erase, but I have to use this to make it clear to you guys. If this is x, this is, I use this capital X, x to the power 23. Now what we do here is this x is gx, therefore we have to replace this x with gx. Gx is what? Gx is this. This is this capital X. So what I'm gonna do is take off this x and put x cubed plus 11. Therefore f of g of x equal to x is x cubed plus 11 this to the power 23. That's it. This is the answer to f composite g. Right? Alright, so let's see why we need chain rule. We need chain rule to differentiate functions like this. Right? Let me write an example. we have fx equals x cubed minus 2, we know how to differentiate this. Right? Just to remind, let's do this. Then f dash x, simply the power rule, 3x 3 minus 1, which is 2 minus 0. Right? I'm not going to write that derivative of constant is 0. So f dash x is this. Now this is the issue. I'm gonna erase this. What if we have this to the power, any power, say 2, right? Can we differentiate this? What we know so far, we have power rule, product rule, and quotient rule. Now one way we can do this is we can write this as a product x cubed minus 2 times x cubed minus 2. Right? After that, this is a product. Okay, we can apply chain rule. That's not chain rule, I'm sorry. Now this is a product, we can use the product rule. Now that's a one way. The other way, without differentiating this, we can proceed and distribute to get an expression. If you distribute, in class we learned without multiplying one by one, we can do this as first term square minus 2 times the product between them plus second term square, which is x to the power first term square minus product between them is 2x cubed, 2 times that is 4, x to the power 3 plus last term square is 4. If you forget distribute and check, you get this answer. Still this is fx, right? This is fx. We do not differentiate yet. Now if you differentiate this, dash x equal to 6x to the 5 minus 12x to the 2. Simply I use power rule, right? Okay. In this way we can do this. Then why we need chain rule? This is where I need the chain rule. I'm gonna erase this. Now just remember what we did. When it is square, I write this times itself, distribute. Oh, I said we can use the product rule here. Still we get the same answer. Now this is where we need the chain rule. Instead of second power, if we have to the power big number, say 22 or 25, whatever higher power, then what you gonna do? Then are you going to write this as x cubed minus 2, x cubed minus 2, x cubed minus 2, 22 times and distribute? It will take forever, right? Means it's more or less impossible to do in that way. Now let's stop right there and learn chain rule. I keep this as an example here. This is Math2003. We'll get back to this example. Before that, let's learn what chain rule means. Okay, I'm thinking, should I do the example straight or learn the chain rule first? No, let's learn the chain rule first. If h, first I should define this function. So let's assume h is a function of x, means h right. But this means these three functions h, f, u. I just took three random functions. All three functions are functions of x. Right now, not if let, then if h equals to f of u. What this means, h equals to f composite u, not times u. Right? In other words, what this means is, write it on the side, it's not part of the chain rule. hx equal to f of u of x. This is exactly what this means. Right? If h equal to f composite u, then we can write dh dx. We want to differentiate the function h with respect to x. Let's see what chain rule is saying. It's saying this is equal to dh over dh du times du dx. Right? This is what chain rule is saying. At a glance, this is just like simple algebra. Okay, if you cancel out this du, then we get dh dx. Right? You may remember the chain rule in that way. You see what I mean? If you cancel out this to this, we get dh dx. It looks like, right? So you may remember quite easily in that way. This is the chain rule. Now let's get back to our original problem, this one. Before this, let's get the example that we did without using chain rule, which is f x equal to x cubed minus 2 to the power 22. Now first we did 2, remember? Okay, let's do that example first. Power 2. Now this is how we apply chain rule. If you take this part as u, then you can say fx equals u to the power 2. Get it? That means what? F is a function of u now. Right? Now what chain rule saying is, in short I write f dash equal to df differentiate f, the original function with respect to u, multiply by du dx. Right? Get it? Now let's do that. In this case, what's u? U is x cubed minus 2. I'm gonna take it out and I write u equals x cubed minus 2 here. Now when we take this part as u, df, I'm just writing single letter f. What I mean is fx, just to reduce the complication. Df dx equal to, we're going, now I showed you f is a function of u, df du times du dx. Right? Now if you take this part as u, then what is f? Then f equals to I use it here, f equal to u square. Then what is df du? Means if you differentiate f with respect to u, f is u square, use the power rule, this is 2u. Right? df du is 2u. This is equal to 2u times du dx. Differentiate u with respect to x. Equal to, we can use again power rule, 3x square. Get it? Du dx is 3x square. Right? Now substitute back for u. U is x cubed minus 2. Then we get 2 times x cubed minus 2 times 3x square. Simplify means you don't have to distribute, just simply multiply this and this. We get 6x square x cubed minus 2. Right. Clear? Now, if you learn in this first time, you may think this is hard. Um, Now, if you distribute, you will get the same answer that we get before. You see, this is what 6x to the power 2 times when you multiply this, and this x to the power 5 minus 12x square. If you want, I write that answer here. If you distribute this, we get 6x to the power 5 minus 12x square. Right? You may leave your answer like this or like this, no problem. I distribute this and showed it because in the first example I showed you when we differentiate this function, we write this as this times the same thing and distributed and then differentiated, we get this answer. To show you that we get the same answer through the chain rule, I distributed. Otherwise you may leave the answer, the final answer, like this. Clear? Now the thing is not too complicated. If you learn it first time, you may think it is complicated, but with the second example, as the second example, I'm gonna do this 22 power. Right? You may think why we need a chain rule, means a different rule if we can distribute and do it like this. But the problem is if we get something like this. Let's do this then. Fx equals to x cubed minus 2 to the power 22. Right? Now this is the thing. In previous example you may thought it is complicated because when you substitute and write it separate, it's too much writing. To reduce that complication, let's do this. What we want to find, df dx. Which is, in short, when you're getting used to the process, you may write simply f dash x or f dash sometimes. Now this is the thing I want to tell you. When we using chain rule, from mind you simply assume this as u. Right? You may write it separately if you're having hard time to imagine that, but if you will see this is quite easy. So this, assuming this as a different function, we simply use power rule. 22 comes here, this to the power 22 minus 1. 22, we take this as a single function, so I'm not going to break that. X cubed minus 2 to the power 22 minus 1. What I did, I simply used the power rule. But what chain rule saying is we have to multiply this by du dx, means the derivative of inside function, which we assumed as x cubed minus 2 equal to u or some other letter. So we got to multiply this by derivative of that. What is the derivative of internal function? X cubed differentiate this, we get 3x square, 3 minus 1 is 2, right? Minus 0. If you want, I write minus 0. You don't have to write that because derivative of constant is 0, right? That's it. Understood? I go through it again. 22 comes to the front. We assume this as a separate function. 22, that function to the power 22 minus 1 multiplied by derivative of that separate function, which is 3x square minus 0, right? That's it. Then simplify this a little bit. We can multiply this 22 and 3x square. We get 66 x square x cube minus 2 to the power 22 minus 1 is 21. Clear? That's it. This looks short and sweet, isn't it? Less complicated, but get used to these steps. Let's see another example. Alright, I'm gonna erase this. Square plus 7. This example from the book, it is in page 253. This to the power 23. This is the third example we're doing. We want to find the derivative of this. Now we know how to use the chain rule. This is equal to, we first differentiate the original function, assuming this as a separate function, 23. Let's call this internal function. This separate function, let's call this internal function, since it is inside. 23, 3x square plus 7 to the power 23 multiplied by derivative of the internal function. What I call internal function is this. I call this as internal function, right? Times derivative of the internal function, which is, differentiate this. Exponent comes to the front, exponent minus 1, right? Power rule. 3 times 2, 6. I have to write this as 6x to the power 2 minus 1, which is 1, plus derivative of 7 is 0, constant. So this is it. Then simplify this a little bit. So this is it, the derivative. 3x square plus 7 to the power 23. Right? That's it. Get it? I'm gonna erase this. Example 4. Now okay, let's do this example. Fx equal to x to the power 4 x square plus 3x plus 5 find f dash x. Now this is a mixed problem. We have to use, either we have to distribute this and differentiate. Now why we do that? Now we know the product rule. This is a product between this and this, means in between what we have, multiplication. Clear? This red cross is multiplication. So what product rule saying? When this is u and v, u times derivative of v plus v times derivative of u. Let's do that. This times derivative of the second function, which is 2x plus 3 plus second function times derivative of the first function, x square plus 3x plus 5, this times the first derivative of the first function, which is differentiate x to the power 4, we get 4x to the power 3. Right? Distribute. Now this is all with differentiation, then simply distribute and combine like terms. 2x to the power 5, 3x to the power 4 plus distribute remember, when we multiply, we add the exponents. Plus 3 times 4 is 12, x to the power 4 plus 20, x to the power 3. Combining like terms, we get this and this, 2 and 4, 6x to the 5, this and this, 3 and 12 is 15, 15 x to the power 4 plus 20x cube, right? Get it? That's the answer to this question. Okay, let's do another question. Let's do something different. Now I believe you guys familiar with these rules. Let's do a different question where we apply this concept derivative. Let me find a question. Okay, this is from the book. Find the equation of the line tangent to. This is in page 254. Page 254. Tangent to y equals 4 divided by 3x minus 1 at x equals 1. See if this question is clear to you. Find the equation of the line tangent to this at x equals 1. Means the shape of the shape of this is a curve. This is not a straight line. It could be anything. Don't worry about the shape. We want to find the derivative when at x equal to 1. Means let's assume you don't know the shape. It could be any shape like this, say like this, and x and y when x equal to, let's get a random place, say here, this is x equal 1. What we want to find? We want to find the equation of the line, tangent line. I'm going to draw a tangent line here. Line touching this point and tangent to this curve at x equals 1, right? So I hope the question is clear to you now. Right, now what we want to find, let me do it in red. We want to find the equation of this line. Equation of this red line. It's a straight line. So the theory of equation of line that we learned in class, that's not going to change. Again, I'm going to ask the same question that I asked 100 times in class. What are the things that we need to write the equation of a straight line? We need slope of the line and coordinates of one point, right? Now the slope of the line, we don't know, it's not given. It said at x equal to 1. We know one coordinate, which is x coordinate. X coordinate is 1. Then what is the y coordinate? We know this point is on this line. This is this is our y given by 4 divided by 3x minus 1. So we can find the y coordinate. What we do, we substitute 1 here, then we get the y coordinate. If you substitute 1 here, we get 4 divided by 3 times 1 minus 1. 4 divided by 3 minus 1 is 2. Y coordinate is 4 divided by 2 is 2. I write 2 here. Okay, we know coordinates of one point. What we don't know is the slope of the line. Now we learned slope of this line is the slope at the derivative of this curve at this point. Derivative of y at this point is same as slope of this red line, right? Means if we can find the slope, this is what we're going to do. We find the general slope of this curve y, and then to find the slope at this specific point, we substitute this coordinate and find the slope of this red line, right? To find the general slope, we differentiate this function. Okay, this we can write it as y equals 4 times 3x minus 1 to the power negative 1. Agree? I move this whole thing to the top, therefore it is negative 1, negative first power. Now let's differentiate this. Y dash equals to, leave this 4 outside. Now we use chain rule, negative 1 3x minus 1 to the power negative 1 minus 1, which is power rule. Then what chain rule is saying is multiply this with derivative of the internal function, which is 3 in this case, times 3. Now let's simplify this. 4 times negative 1 times 3 is negative 12. 3x minus 1 to the power negative 1 minus 1 is negative 2. We can write that as 3x minus 1 to the power positive 2 in the denominator, right? So this is y dash. Then we want the derivative at this point. That means when x equal to 1, y dash when x equal to 1. What does this mean? Y prime when x equal to 1. To get that, we simply substitute 1 here. Three times 1 minus 1 to the power 2 negative 12 divided by 3 times 1 is 3, 3 minus 1 is 2, 2 square is 4, negative 12 divided by positive 4 is negative 3. Right? Now we know the slope of this line. M is what? M equals negative 3. This one is x coordinate, right? Now we don't want any of this blue stuff now. Focus on this red line. We want the equation of this red line. We found the slope is m equals -3 and we need this coordinate. That's all we need, right? To write the equation we need slope and coordinates of 1 point. Once we have that, we can use y minus y1 equals m x minus x1. Y minus y1 is 2 equals to m is -3 times x minus x1 is 1. Y minus 2 equals to -3x. -3 times -1 is +3. Add 2 to both sides, we get y equals -3x plus 5. Clear? So slope of this line is this. Right? Okay. Other questions also pretty similar to that. I'm just going to show you one other example. I'm gonna erase this. Example 6. Square root of x square plus 3 divided by x square plus 8. Now I picked this example because I know some of you guys scared of this radical sign. Now in this case, when we got to find derivative, express this expression in exponential form, means convert this radical form into exponential form. We know when we have simply square root, simply 2 is in this little pocket, that means half power. We can write this as x square plus 3 divided by x square plus 8 to the power half. Right? Now we can differentiate this function f(x). We get f dash x equal to, first use the power rule. This is the internal function. This thing in red, that's the internal function. That to the power half. So differentiate this half. If you want, write this red thing as u. This is your u. Right on the side u is this. Then differentiate that first. If not, simply do it. Okay, I write that 2 on the side. U in this case is x square plus 3 divided by x square plus 8. Then find du dx separately if you want, but in my view, when you write more, it looks more complicated and it confuses yourself. So I try to keep it simple. Okay, half, this is the internal function, so the derivative of that with respect to u is x square plus 3 divided by x square plus 8 to the power half minus 1 . We got to multiply this with this little cross is multiplication with the derivative of this internal function. Now you see this is a quotient. We got to use quotient rule. This times denominator times derivative of the numerator now this whole thing I put in parentheses. What I'm putting in this parentheses is the derivative of this red function u, x square plus 8 times derivative of the numerator, which is 2x minus numerator times derivative of the denominator, x square plus 3 times the derivative of the denominator, again 2x divided by denominator square. I'm using quotient rule. Right, now this is the derivative. After that, algebra. Half minus 1 is negative 1/2. Distribute now this we can simply flip this over and make this exponent positive. Multiply by, okay, let's simplify this. 2x cubed negative 2x cubed, these two terms cancel out. 16 minus 6 is 10. X divided by x square plus 8 to the power 2. then 2 cancels with this 10 and we get 5 times x square. Okay, now I got to erase the top part of this. I'm gonna erase this part because I don't have enough space in the bottom. Two times 1, 2 times 5. We get 5x first of all. 5x. After that, what else we get? X square plus 8. Now we can separate these two like this. You will see why I am doing this. X square plus 8 to the 1/2 divided by x square plus 3 to the power 1/2. And we have to write this part plus 8 square, right? Now this is equal to 5x divided by x square plus 3. We see x square plus 8 here, x square plus 8 here. We can simplify this, but it is not that we can cancel them out. We cannot. They have different exponents, but we can combine them. 3 to the power 1/2. If you move this to the denominator, it will be negative 1/2. Then when we multiply that and this one, we get x square plus 8 to the power 2 minus 1/2. Okay, so I'm gonna erase this. We get 5x divided by x square plus 3 to the power 1/2 times x square plus 8 to the power 2 minus 1/2 is 1 and 1/2, which is 3/2 or 3/2, right? So this is the final answer. Get it? So some of you may find this hard because of algebra, not because differentiation. Finding derivative, we learned power rule, product rule, quotient rule, and chain rule, right? 4 rules we learned so far. If you have any questions, let me know. You always ask. I'm telling you, feel free to send me emails. I respond to most of your emails, right? So this is all I'm gonna do for today. So stay safe, right? Take care.